In this video, I'll be solving another first order linear differential equations. In my previous video, I didn't really show the steps of how to do it. I just set the steps. So in this video, we'll be showing the steps along with it. So first things first, we need to figure out, is this a linear differential equation? That's the first thing that you need to figure out. Is this a first order linear differential equation? Yes, it is linear differential, but it is a first order. Well, right off the bat, it does seem like a first order from what we see. It has a y prime, right? It has only one order. Okay, so second, we need to figure out what format does this have to be in. Does this abide by the format that we're given, right? So the format that we're actually given for an actual, first order linear differential equation is, y prime plus some function times y equals some function, okay? And does this make sense? Is y prime by itself? No. It has this x beside it. So what could we do? Is there anything that we could do to prevent that x from being there? So the mathematic way to do it, one mathematic way to do it is divide this whole thing by x. What does this do? It removes this x and just distributes the x all across, okay? So this becomes y prime plus 1 over x y equals x plus 1 over x. Cool? So our new question becomes this. Okay. Second, well, this is the first step. So the first thing we just need to do is just figure out, if this is a first order linear differential equation. And we figure it out, it is. The first thing we have to do is figure out an integrating factor. And how do we do that is we need to just use this formula. So this becomes e to the power of, what is p of x? P of x in our case. So this was dy over dx. This right here, the 1 over x is p of x. And this whole thing is q of x, okay? So what is our p of x? It is 1 over x, right? And so the integration for 1 over x is just ln x. And there you go. So there's some exponential rules that we must follow to make our lives easier. E to the power ln x is just x. It's nothing but x, okay? And so there's some expression that you need to just refresh upon in your memory. If you didn't know this, what you could do is just use your calculator and e to the power of ln 10. You'll see that's equal to 10. E to the power of ln 20. You'll see that's equal to 20, okay? So finally, e to the power of ln x will give you whatever that's in the argument, which is x, okay? Which is this. All right, so we figured out our integration factor. Second, we need to multiply this integration factor across our whole equation, okay? Now look at the magic in this. Okay, so life just got easy, right? So what I did is I just distributed x across our original equation, the one that we were given, and I just multiplied the integrating factor with the example that was given, and that's the way that you're supposed to do it. So this is the step, okay? And in blue, it's my integrating factor, and as you can see, this becomes xy prime. This x cancels out, okay? And also, let me just change the color. So this x cancels out, and this becomes x squared, and this x cancels out. Cancels out meaning that it becomes 1, it becomes 1. So our final equation, we're not done yet, our final equation is xy prime plus y equals x squared plus 1. Okay, cool. Now here, we need to integrate. We have to integrate both sides. So we have to integrate here and here because we're done. We're done multiplying the integration factor. So we have to start integrating, okay? Now to make life easy, instead of integrating both sides, this side, and this side, what we could do is just use this simple formula. And why this comes in clutch is that at the end of the day, once you do all the nitty-gritty work, you will still get this idea. So might as well just copy it and paste it, or always practice it and learn it. So what we're going to be doing is using our integrating factor, x, and then multiply by y equals the integration of the function q of x, which in our case was x plus 1 over x, so x plus 1 over x times the integrating factor, which is x dx, okay? Now we just need to figure out the integration here and keep this constant. So this is just very straightforward integration, right? And do not forget, okay? This is very key. A lot of students forget this. The plus c, okay? It has some constant. This is something you cannot forget, okay? Make sure you always have some constant. Now this is fairly simple. All we have to do is make this y by itself and divide x across. So this becomes 1 over 3 x squared plus 1 plus c over x, which, to write it better, it's 1 over 3 x squared plus 1 plus c x to the power negative 1. Okay, and that, my friends, is your solution to that first order linear differential equation.